And for our second example, we're going to use the same data set, but this time our research question is there a difference in the serum creatinine level of Hispanic dialysis patients from the normal healthy population? Our dependent variable is serum creatinine level, which is on a scale, and the population mean, we're going to use a test value of 6.5. We'll go through again and check to see if we have any outliers. So we go through SPSS to analyze descriptive statistics, frequencies. We're going to use the variable for serum creatinine, and we're going to move that one across to the variables that we're interested in. We're going to leave up the display frequency tables. We'll click on charts. Histogram is checked, showing the normal curve. We click continue and we click OK. Excuse me. And SPSS produces a nice histogram for us. Once again, you can actually see the distribution, and here's our normal curve. And I've circled to the far right on the x-axis that you can see we do have a few outliers there. Once again, we have a sample size of 823, which you can see in the upper right-hand corner, and the mean value is 6.39. So for this example, I'm going to go ahead and just leave those outliers there. If you wanted to remove the outliers, you would take a look at the frequency table, which is also produced by SPSS when you do this function. This is why we actually leave that box checked. You can go and find the frequency of those results of concern to see how many are actually present. And then you can go through the process of actually removing them, or having SPSS consider them missing values. And that's one way of taking them out of the analysis. So now we're going to run our analysis. So we go back to the Analyze drop-down menu, compare means, one sample t-test, just like we did before. We'll move across the serum creatinine level, and in the test value box, we'll put in 6.5. We go to options, we click on options, radio button, the confidence interval percentage, 95%, just to be sure that that's where we're at. We'll click continue and then OK. And then we look at our table, sorry, the one sample statistics. We can see our sample size is 823. Our mean value is 6.3874, standard deviation 3.42. Standard error of the mean is 0.11923. These numbers here we'll actually use in our APA style write-up. That's why it's important to take a look at this table as well. For the next table, the one sample test, we can see that in the top bar our test value is equal to 6.5. We see our variable, serum creatinine. Our t statistic is much lower this time. It's negative 0.945 with the degrees of freedom of 822. And this time our sig, our two-tailed sig value is 0.345, so it's not a significant result. We can see the mean difference is far less. It's negative 0.11262, so it's actually very close to 0. And if we look at the 95% confidence interval of the difference, we'll see the lower is negative 0.3467, and the upper is 0.1214. So the confidence interval range actually includes the value of 0, which is reflected in the sig value of being non-significant of 0.345. And for our APA style write-up of the one sample t-test, the results of the one sample t-test show that the mean serum creatinine level of Hispanic dialysis patients, mean equaling 6.39 with standard deviation of 3.42, was not statistically significant at the 0.05 level of significance, t equaling negative 0.944, degrees of freedom is 822, with the p-value greater than 0.05 from the test value of equaling 6.5. The mean difference equaled negative 0.113 with the confidence interval of negative 0.347 to 0.121. The null hypothesis, which suggested that there was no significant difference in the mean serum creatinine level of Hispanic dialysis patients, cannot be rejected. And so that's our APA write-up for a one sample t-test where it's non-significant.